2020 question 1. We're told f of x is equal to x squared plus 5x plus p, and we're told that x is a real number and p is between minus 3 and plus 8. P is an integer. Find the value of p for which x plus 3 is a factor of f of x. So I think the best way to do this, if you've used the box method for cubics, you can apply the same method when you're dealing with quadratics here. So my quadratic is x squared plus 5x plus p. So I put my first term here and my last term here, and I put my factor on the outside, x plus 3. And we divide in and we see what we get. So my x into my x squared, put my answer on top as x. X times the 3 here at the bottom goes in here, 3x. I need 5x, so I need another 2x inside my grid. And x multiplied by plus 2 has to give 2x. And then you can see here 2 by 3 gives p. So p is equal to 6. Part B, find the value of p for which f of x have roots which differ by 3. So they're testing here your knowledge of these quadratic and the nature of their roots. All quadratics are written in the form x squared minus x times the sum of the roots plus the product of the roots. So what can we tell here? If one root is x and they differ by 3, so we can call the other root x minus 3 or x plus 3. So the sum of these roots is 2x minus 3. Our quadratic is x squared and it's plus 5x, so it's minus x by minus 5. That's going to give me plus 5. So we're going to get 2x minus 3 is equal to minus 5, or 2x is equal to minus 5 plus 3, which is minus 2. So x is minus 1. So x minus 3 is equal to minus 4. So my roots are minus 1 and minus 4. So this will be a quadratic x plus 1 by x plus 4 to give me your 5x. You can see that p is 1 times 4. P is equal to 4 in part B of this question. Part 3 of this question, find two values of p, two values for which the graph will not cross the x-axis. If it doesn't cross the x-axis, we can say that it has no real roots. So what do we know about the nature of quadratics? B squared minus 4ac is going to have to be less than 0 here for it to have no real roots. So just write our equation again, x squared plus 5x plus p. So a is equal to 1, b is equal to 5, and c is equal to p. So 5 squared minus 4 by 1 by p is less than 0. 25 minus 4p less than 0. So we could say that, well, we could say that 25, if we leave it there, is less than 4p. So if we reverse that around, 4p would have to be greater than 25. So p would have to be greater than 25 over 4. So my values for p can be equal to, has to be greater than 6.25. My range of values was between minus 3 and 8. Let's just double check here. Between minus 3 and 8. So what values of p are greater than 25 over 4? P is going to be equal to 7 and 8. And that's the end of my range of values. So there are the two values for this part. And in the last part, we have a modular equation. The range of values of x for which 2x plus 5 minus 1 is less than or equal to 0. So the modulus of 2x plus 5 has to be less than or equal to 1. If we square both sides, we're going to get 4x squared plus 10x twice, which is 20x plus 25. And if I bring the 1 back across, less than or equal to 0, because I'm squaring the 1. So I'm going to get 4x squared plus 20x plus 24 less than or equal to 0, divided by 4, x squared plus 5x plus 6, this same equation again, less than or equal to 0. And if I factorize that and do a quick sketch. X plus 3 by x plus 2. Where is this quadratic less than or equal to 0? My factors are plus 3 and minus 2, so minus 3 and minus 2 for my roots. So I'm just going to move my y-axis across. I've got a minus 2 and a minus 3, and it goes across the y-axis of plus 6. So if I sketch this quadratic down and a bit wockety, back up, down and up, it's only a sketch, to be less than or equal to, R value ranges in here. So x is between the values of minus 3 and minus 2.